Hello everybody, this is another video of our AIOps Explained. Today we're talking about an air-gap installation of the AI Manager. We're talking here of the Cloud Pak for Watson AIOps, and the version we're using today in the video is the version 3.2.1, which has just recently been GA'd. My name is Fred Klein. I'm located in Berlin, and with that, I'd like to hand over to Vijay and Taylor to introduce themselves. Vijay?
Thanks, Fred. Hi, everyone. My name is Vijay Kalathur, and I work on the development team for Cloud Pak for Watson AIOps, based in New York.
Thank you. Taylor?
Thanks, Fred. And I'm Taylor George. I'm based out of Austin, and I work with Vijay in the development of Cloud Pak for Watson AIOps.
Cool. So let's talk a little bit about what are we going to show today. And for that, I do have prepared a few slides. Usually, our customers are using our software in several stages. They have the software in a production environment, they do have a test environment, and they do have a development environment. This is a three-stage approach in most of the customer environments. But usually when we are, for example, in a telecommunication environment, the production environment is not connected to the internet. And if we do have to have an internet connection to draw images from the internet or take other software pieces out of there, then this provides a problem. So therefore, we need to have a special product support in here, which really addresses this kind of approach. And therefore, we are making this video how to install the Cloud Pak for Watson AIOps in an air-gapped environment. And the prerequisites that we are taking today is we are considering that you already have a software repository installed locally as well as an OpenShift environment. And today we're putting on top then the software modules into the repository, as well as we're going to kick off the installations. And this will be the demo parts, which Vijay and Taylor are going to take us through. Let's begin at the beginning. So what are the components that we do have in our customer environments? So typically we find in almost all customer environments a hybrid installation. So we do have an event manager installation, which is most of the time installed in a virtualized environment. So we do have virtualized machines or bare metal machines, various components in here. And when we add the other parts of the solution, like the AI Manager, which we're talking about today, then this is based on an additional OpenShift cluster, which needs to be embedded either in the customer environment in their data center, that's a local install of an OpenShift cluster, or you could also have a cloud-based installation of an OpenShift installation. But when you do have a cloud-based installation of OpenShift, then you are already interneted. We're considering today we are not interneted. We are in the local data center of the customer, and the production environment we're installing to does not have any access to the internet. So therefore, we need to place our software into this air-gapped type environment and install our products in there. So there's another method of making these kind of architectures. You can also have everything that was here in the first slide in a hybrid way approached and installed. All of that can be placed into a single cluster of OpenShift as well. So we would have a local installation of OpenShift in the customer environment, air-gapped, and we would install the netcooled parts in here, the AI Manager parts in here, the metric manager parts, which are coming in the next version, all on that single OpenShift cluster in the customer environment. And today we're showing how to install this AI Manager piece here in an air-gapped environment where we're not capable of fetching any kind of software from the environment. So this is the scene. This is what we want to talk to. Of course, we have documented all the steps in the Cloud Pak for Watson AIOps documentation set. So here you can see this is the most recent version, 3.2.1. And you typically start an installation with planning your installation. So you want to choose what kind of integrations do we want to have in there, what kind of things do we want to see in here. So therefore you have a planning stage as well as you do have a later installation stage, and all that is the procedure how to get the whole things running. So after planning comes the installation. Just to say again, we are considering that we're going to have an existing installation of OpenShift. So this is one of the ways how we can install to an air-gapped environment. So we need something that carries our software, which is, for example, the Bastion host, and we need a local image registry that takes the software where we're then installing from onto the cluster. And the installation procedure that Vijay is going to take us through, how to use this kind of setup to really install the software to the OpenShift environments. The registry is here, the OpenShift platform is here, and that will be the scenario of today, how to put all that together. There's another possibility to install this type of environment. This is using a laptop, which has the software installed on it, and then we push the software into the image registry. And the last possibility in here is with another portable device here that can be used to transport the software as well to a local device and then push to the local registry. That is so far for the introduction. I think I spoke enough, and now I'll hand over to you, Vijay. Take it up.
Okay, thank you, Fred. Okay. Hello, everyone. So in the demo today, we're going to be walking through the process of installing IBM Cloud Pak for Watson AIOps, AI Manager in an air-gapped environment using a Bastion host model. So for this, we'll start with some of the prerequisites that are required. We would need an OpenShift cluster that's configured in an air-gapped environment. You're going to need a Docker v2 type registry, which we will be using to mirror the images into, which is also behind your firewall. You will need a Bastion host, which has connectivity to these following endpoints. You will also need to have the integrated OpenShift registry enabled on your OpenShift cluster if it's not enabled by default. And finally, you will need to set up a proxy server to enable access to Slack if you plan to use that feature. The first step is to configure the Bastion host itself. We're going to need some tools on that to drive the actions we'll be stepping through in a minute. So this is a list of software that you're going to need on the Bastion host. Pretty standard tools, and we have commands in the documentation that walks you through the steps to install those, and they should be pretty easy to follow along. The next section talks about setting up the local image registry. For the purposes of this demo, I already have one configured, but you can read through the details if needed. And then before we actually jump into running the actual commands, we do have a link to a PDF version of the documentation that we're following today. So if you'd like to have access to this in your air-gapped environment, you can grab this and transfer it to your Bastion host. We'd also suggest you clone the repo pointed to over here, which has access to some useful scripts and tools like the uninstall script and the prereq checker script, amongst other things that would be handy to have access to in your air-gapped environment as well. There's also links to the Red Hat documentation in a PDF format as well. Okay, so let's jump into the actual process of getting our environment ready to do an installation. So the first step is to set up a bunch of environment variables, which will be used by the actions we'll be running. First half of this, nothing to do, just copy and paste. So I'm going to do that. Okay, then the next set of things you would have to update with your specific environment info for your local image registry, usernames and passwords and stuff. I have already set that up in my Bastion host. I will skip that in this demo, but it is something you would have to run. So the first case action, so case is IBM's approach to shipping containerized software. We would have to go grab the case for Cloud Pak for Watson AIOps. So I'm going to copy that command and run it on my Bastion host. So this runs pretty quickly. So it's basically grabbing the TGZ files from IBM GitHub repo where this is stored, unzips it, and makes it available on your Bastion host. There's a quick verification command just to make sure that happened. So we'll check on that. So we see all the TGZs and the CSVs, which contain the list of images we're going to mirror available on your Bastion host now. Okay, so the next step is to set up some credentials and to mirror the images into your local one. We'll go through kind of the simple path here. If you want to, for example, copy the images into specific prefixes and things like that, there's some additional options you have, but we'll kind of stick to the simple path for today. So the first step for that is to enable access to the IBM container registry where all the product images are stored using your IBM entitlement key. You can follow this link to get your entitlement key for that. And once you export that, we're going to run this command, which again, I've exported my key in my environment already. So I'm just going to run this command, which will then create access to this registry, my Bastion host. And then we're going to do the same to enable access to the local Docker registry we have, which is where we're going to be copying the images into.
Really cool. And this way, you really save me a lot of work because I do not need to blur out all these credentials.
Yeah.
Thank you for that.
Yeah. And the next step is to log into your host. In my Bastion host, I already used my kubeconfig to do that. I'm going to export the namespace. This is the namespace I'm going to install my product into. So I'm going to call it CP4WAIOps. I already have this namespace created, so we'll just confirm. Okay, so I have this created and I already switched into that. So we're good with that. The next step is to configure a network policy to enable routes. If this is not already configured, we have a command I'll check and update if needed. Now that we're done with that, the next step we're going to jump into is so two options here. So this step is basically to either create and configure a certificate for your registry on your OpenShift cluster as an alternate. If you're just doing this for the first time in a kind of like a test environment, and you just want to not create the certificate and stuff, you can also configure insecure access in the OpenShift cluster resource. If you do want to set up a certificate, the command is here. You can run this in your VM that's hosting your registry to generate the certificate itself. And then if you jump to this doc, which goes after this, there's a pretty easy procedure. It's 2 steps. You have to create a config map with the certificate, and then you have to patch the cluster resource with the config map name, which will then enable OpenShift to use that certificate to talk to the registry itself. Okay, so again, as part of my prereq and to save time for the demo, I already have that configured, that access configured. So then we're going to log into our registry from the Bastion host so we can talk to the registry to pull the images. And then we're going to run probably the main command that does the most important step, which is to mirror the images. So now that we have all the access set up and the registries configured, we can run this command. And this is basically going to go, as you can see, a lot of images. It's going to go copy 1,455 images from the IBM container registry into your local registry as well. So the combined size of this is about 120 gigs. So it generally takes a bit of time. On average, it's taken me about an hour or so. And based on your network speeds, it can be a little bit faster, a little bit slower than that. We're going to take a quick pause now, and we'll come back when the images have been mirrored over, and we'll continue on to the next steps after that.
Is this a self-signed certificate you're using here?
In this case, yes, this is a self-signed one. So if a user has something else, they can use whatever certificate that they have for their VM. So, almost done. Just a couple more commands and we're good to go. Okay, so now we have successfully completed the mirror image case action. So we should have all the 1,455 images copied over into our local registry, and we should no longer require internet access to use those images in our local OpenShift environment. In order to make that happen, there's one additional step we would need to do on the cluster to make that happen, which is the next action we'd be running, which is configure cluster air gap. So I'm going to kick that off. So what this is doing is just basically updating your global pull secret with the credentials for your local image registry. And it is also creating this image content source policy, which tells your OpenShift cluster that whenever a pod, for example, is trying to access an image in this source, it will automatically try to find it from your local registry instead. So if you're using OpenShift 4.8, this action is pretty much complete. If you're using an older version, this will trigger a reload of your nodes. So it might take a couple minutes for that, or a few minutes for that to happen based on your cluster setup. But you can run then jump to here. You can run the OC get machine config poll command to verify your nodes are all in a happy state. In this case, I have 3 nodes, which are all updated. So we're kind of good to go. Step 5, it mentions this as an optional step. If you did not want to configure the certificates that we talked about earlier, you can run this command, which will again patch the same cluster resource, marking your registry as an insecure registry, and it will enable access to that without the certificates. If not, it's going to complain with the X509 error messages. Okay, so we're almost done. So the next step which we quickly talk about, is storage. To install Watson AIOps, we do require you to either configure storage using Portworx or OpenShift Data Foundation. This documentation kind of walks you through the steps to do that. Steps for this, the end result is the same. You're going to need those storage classes created, whether you're doing an online or an offline install. The process as to how you would install those are obviously a little bit different between online and offline. Okay, so finally, now that we have everything set up, we are going to then run a final case action, which is to go create the catalog sources from which we will be installing the Watson AIOps operator itself. So this command takes a minute or two to go create. It creates about a dozen catalog sources. And then once this completes, we're now ready to move forward with the final step that's listed here to go and install the Cloud Paks for Watson AIOps AI Manager operator and create the installation CR to kick off the installation of the product itself. And Taylor will be walking us through those steps. Okay, so now a final case action to create the catalog sources is completed. We can do an OC get catalog sources in the OpenShift marketplace namespace to check. So we see all of these catalog sources have created successfully. So we are good to go and move forward with the installation, which Taylor will walk us through. All right, thank you.
Thank you, Vijay, very much. Taylor, over to you.
Thank you, Fred and Vijay. All right, here we have the documentation to follow. I'm going to install the operator through the CLI here, as we were connected to. I'm going to create an operator group here for the operator managed installation. As part of this, I have to fill in our namespace that we're deploying to. So I will do that, and then I will run the command. And we get an operator group created. I'm going to now create the operator itself. I also have to fill in a namespace here for scoping of the install and security permissions. So I will go ahead and provide that value and then apply that again. And then the operator subscription has been created. So now it may take a few minutes, but I need to run this command to verify. So I will prepare that. And again, putting in the specific namespace we have here. And let's see what that shows. Okay, looks like we are succeeded. So I will look at the next steps here. I'm not going to do an optional step. So I will look at creating the custom resource in the CLI path, which is why I skipped that. Did not do a customized IAF, so I will go to this next section. Let's go edit some of the properties here that I'll need for my installation. So the first one's a name that I will choose, and then the namespace that we've been preparing up to this point. And these are presented to me in the documentation on the left. So I will look for some of the other info I have to populate here, such as license and proxy, because we are in an air-gapped environment. So going to do a small for demo purposes. And then I have to look for an image pool secret, but in an air-gapped environment, I should leave that field empty. So I delete that. I will accept the product license. Then as noted, I have to put in some proxy info. Okay, now I've enabled some of that configuration, but I have to get the storage from the environment. So there's two different storage here. So I'll do the file system one first. On this environment for demo purposes, we have Rook Ceph set up. So I have the Rook Ceph FS configuration, and then I back out to refresh my mind on the block storage name. If the names aren't correct, the installation will let you know that, and you'll need to go update the values, but making sure I get it right here. And then I will be able to make sure everything looks good and then run that. Okay, and so that's created. I'll make sure I'm in the right context here. Cloud Pak for Watson AIOps namespace. And then told to run this verify deployment command, so I will set that up. Again, with the instance name that I chose, and then the namespace or project that we have been preparing up to this point. And so here I will see that it is updating, and given the understandings of the product, it says that I will have to wait a few minutes here. So I will go get a coffee and come back to check the installation. All right, so now some time has gone by. I'm gonna go ahead and just recheck that verify deployment. Okay, things are looking good now. We're running, and I will verify the installation here. Okay, great. So things are running, and the status of the various components are reporting ready and complete. Okay, so that completes the installation of the Cloud Pak for Watson AIOps, the AI Manager component in an air-gapped environment, that we have all of these workloads in our project that are running the software inside of our air-gapped network. Okay, and now that all we have observed that the offering is deployed and running and all the states look happy, the next step would be here to identify and access the console. So we could take a look at how we would do that in order to access at certain points. So here we go to get a route, and we will the namespace where we are installed here. And so here we have a route that we would connect to within the single quote, such as an example here. And then we would be able to find some access credentials, which I will show you the procedure for, but understandably the connection info is confidential. So here we have a command to extract a username. So we will save that off. And then we have here a complementary command to get the admin password from the environment as well. And so a cluster admin would be able to come in to this Bastion host and receive the console credentials in order to log in at that application route. And then from this point, cluster administration can configure egress network policies aligned with the firewall rules and requirements of the business, and for the connections required by the use cases. Again, some final configuration around certificates and security to be done. And that's where I'll stop.
Very good. Thank you very much, Vijay and Taylor. That was very interesting. And I hope to see you all in our next video, whatever that will be. At the moment, we are considering to talk about runbook automation in the next video, but that may change. But if you do have a topic that is going to interest you, just let me know. My name is Fred Klein. My email address is on the front page, so leave me a text or put it here into the YouTube environment, whatever you choose. I wish you a nice day, and thank you very much, Vijay and Taylor, for participating in this video, and see you another time.
Right. Thank you, Fred.
Thanks, Fred and Vijay. It was a pleasure.